Good morning, everyone. I My book basically starts with the sediment management. We look into the what I'll start. I'll give a context of why sediment management, why I'm generally looking into the sediment management, and especially within the Indian Ocean region itself. And when we talk about sediment management, what are the different nuances that we are talking about? What is our focus? And when we talk about those nuances, what are the challenges that we management, inland water management, or the watershed management, and then where are the practical scenarios, or what are some real life applications we can use digital technology, digital transformation to actually solve those challenges. Now, with the current geopolitical scenario, we have seen how the Indian Ocean region is a very strategic space, especially when we see that it carries over 50% of the global container traffic, 80% of the total world's shipping lanes as well. And it is of interest of almost every global power today. So we have seen news of the Chinese vessels serving within the Indian Ocean region. So there is a lot of geostrategic competition within the Indian Ocean itself. Even with its vast geostrategic importance, the Indian Ocean still remains one of the least studied regions of the world. So there are significant knowledge gaps of understanding of the sediment dynamics. What are the various natural or anthropogenic activities that affect the sediment flow and the sediment dynamics itself. Now, within the inland context itself, sediment is a very crucial challenge. Now, as we can see within in the topmost image, so you can see like the before monsoon, the pre-monsoon, and the post-monsoon. How much of this sediment influx has happened in the Gulf of Khambhat itself? Now, superficially, we believe that a lot of sediment has led to increased turbidity, and it might have effects on the shipping, on the fisheries itself. But again, we need to have proper nuanced understanding. So we need to go from a macro picture towards a more micro picture to understand what are the various challenges that might come up with such increased sedimentation or the deficit in sedimentation. Okay, this also has effect on the overall watershed management as well, where we see that increased sedimentation or increased siltation affect the storage capacity of reservoirs, and then it affects the water quality, which is detrimental to the marine and aquatic habitat itself. Now, as you can see in this picture itself, the siltation which occurs within the Bay of Bengal or within the Indian Ocean region, it's one of the highest in the world. In fact, the Ganga Brahmaputra rivers, they carry across about 1 billion tons of sediment within the Bay of Bengal, which remains one of the highest in the world. So we require very unique understanding of what are the local conditions happening that give rise to such high loads of sediments within our region. So this is where we look into sediment management. So our basic understanding is to understand how the sediment gets accumulated, how does it move, settles, and then accumulates or deposits within our different riverine systems and the coastal systems itself, especially looking into the unique conditions. So we have the monsoonal system, high rainfall, cyclones, and then other anthropogenic activities as well. So how these highly variable characteristics affect the sediment management within our Indian subcontinent and within the Indian Ocean itself. Uh, so we look into something which is called the UDA-driven sediment management. Here we talk about how data-driven decision support can help in understanding the different nuances of sediments, how we can look into or how can we tap into the data and look and apply various new technologies such as AI, machine learning, or use some data analytics to actually understand what challenges are there regarding the sediment, and how can we bring all of them together to actually solve sediment related challenges, be it in the coastal systems, be it in freshwaters, and so on. Now, coming to understanding what are the unique characteristics of the sediment within our Indian conditions, we firstly need to understand that these Indian conditions, they support a high sediment load and high turbidity, especially from the Himalayan regions or from the peninsular regions. Afforestation, a lot of increased farming, it leads to an increased sediment load within the Indian rivers itself. When we combine it with the highly fluctuating monsoon, climate change, it leads to a lot of sediment loads with the intense rainfall and the increase in the catchment erosion as well. We also have a rich biodiversity. In fact, India is a mega biodiverse country itself. The Indian Ocean region also supports a lot of endemic species in itself. So how these biological activity, how those biological species are getting affected by the increased sediment loads or the decreased sediment loads, because these sediments carry the nutrients which are very much required for their healthy spawning and the species distribution in itself. And then we have excessive anthropogenic activities as well. So we have a lot of fishing, trawling, dredging itself, how shipping affects the sediment redistribution itself, how the propeller movement might lead to the redistribution of sediments, dredging can lead to the resuspension of the sediments itself. So ultimately, how all of these activities, with the natural activities, with the human activities, how this leads to the local sediment dynamics. And then we also need to consider the climatic conditions, the chemical properties of the Indian Ocean region as well. We also need to consider the strong temperature gradients. It remains one of the warm water bodies of the world. So how the temperature gradients affect the overall species distribution as well. And then to monitor the underwater, we have something called the acoustics. So these acoustics mostly are based on the principle of underwater communication itself. And the underwater communication based on the speed of sound. So how the temperature gradient, the salinity, the pressure, how those gradients affect the overall speed of sound, the underwater communication. That is a very crucial understanding that needs. Another major understanding is the depth of sound access or the SOFAR channel depth. Now, SOFAR channel is can be considered as a channel which is required for the long range communication, long range underwater communication without a lot of attenuation. Within the tropical Indian Ocean, this lies in the range of 2 to 3,000. At such depths, the normal sonars, the efficiency reduces to around 60 to 70%. So how that reduction in the overall efficiency of a sonar or underwater communication channels, how that affects the our understanding itself. And again, we have a lot of complex reflection and multi-part acoustic propagation due to the biological noise, the shipping noise. So we need to understand what are the different noises that are coming for our underwater communication itself. So, so as you can see here itself, the sea surface temperature or the salinity profile as well, it varies a lot for the Indian Ocean region itself. Now, even when I consider the salinity profile, you can see the Bay of Bengal and the Arabian Sea. They are quite distinct in itself due to the freshwater, a lot of freshwater rivers draining within the Bay of Bengal. So we need to consider this local change itself to see how that affects the underwater communication or the acoustic communication itself. And then, as I mentioned, we have a lot of species distribution as well. So how the sediment load affects the spawning rate, how the species distribution are affected by the sediment movement, by the pollutants which are released within the sediments itself. Then the major consideration that we need to have is that the region itself, it hosts over 2.5 billion people, but these are mostly the lower to lower middle GDP income countries. So we can't just say, okay, we'll have expensive technological solutions developed within the advanced economies. We'll import them and then directly use them. We need to understand what our own conditions are. How can we leverage our human resources? Again, because of the young demographic, which is mostly below 30 years, how are we going to leverage that come up with a new region-specific systems or to manage sediments, to monitor sediments and see how they're affecting the livelihoods and the overall socio-economics of the region itself. So this is where, again, when we use any kind of acoustic systems or sensors, most of them, they are affected by the propagation variability, which are affected by the ocean climatic conditions, the waves, tides, currents, which are continuously fluctuating, especially within, as we are seeing now, the El Nino and the La Nina conditions. There is a lot of background noise interference from the biological noise, the shipping noise itself. All of this make the overall deployment and the calibration of such equipment, which are mostly imported from the advanced economies, very difficult. And it leads to a reduction and leads to an overall effective performance of just 60 to 70%. So, technology for which we are spending more but are getting less efficiency. So that's why we need to really look into how our own region-specific systems might look. Now, coming to the sediment management, we are mostly concerned by two nuances. One is the sediment transport and another is the sediment classification. So sediment transport, we are mostly focused on what are the various factors or parameters that affect the movement of sediments. Now, these might be different in rivers, in oceans or reservoirs. So the freshwater and the coastal dynamics, they are quite distinct from each other, as we'll see in the next slide. And once these sediments are deposited, how they affect the other applications, like we have the sediment bearing pressure, benthic ecosystem, abiotic elements that we'll look into this later on. So these are the two major domains that we are currently working on. Especially, I talked about how the coastal and the freshwater systems swing. So when we talk about the coastal and the freshwater system, the major or the distinctions are between the transport mechanisms, where the coastal systems are affected by the tidals, by the waves, by the littoral drifts. While for the freshwater system, we are mostly concerned with how the river flow is happening, how the discharge rates, or how the releases from the dams itself affect the overall sediment flow, the water discharge levels. We have different infrastructures to keep in mind, like the coastal systems might affect more of the ports, the navigation, the coastal infrastructure itself. While within the freshwater systems, we might look into our dams and reservoirs, how the structural stability is affected, the irrigation and the navigational channels in itself. So each of them, for the coastal system, for the freshwater system, we have uh, different issues, different parameters to look into. So these are quite distinct. However, for the sake of the current discussion, we'll just go around a brief discussion of both of them. Now, as I mentioned that there are two most mechanisms that we are looking into. One is the segment transport and another is the segment classification. But why are we looking for like both of them? Why aren't we looking just one for segment transport and why we are looking to segment classification and so on? Because they both are coupled together. In fact, when we see that the sediment transport is actually dependent on the sediment characteristic, on what type of sediment it is. So if I say this, like the sediment type, the material properties affect the settling of the sediments. So if the sediments are less cohesive, say sand particles or larger size particles, they are more susceptible to get deposited. However, if they are more cohesive nature, they of say clay type and are more finer particles, they are supposed to get flocculated and they may give rise to the sediment concentration, give rise to turbidity itself. So in fact, the sediment type affects what would be the sediment transport pathway, how the bed loads affect, what are the different stresses that lead to, or what are the forces that lead to the overall settling velocity. So the sediment classification and the sediment transport, they are correlated with each other. And that's why most of the sediment transport modeling can be done by using fundamental physics equations, using the Navier-Stokes equations. We can have what are the bed load and the suspended load itself. And then there are various softwares which use what are the flow conditions, the discharge rates, what are the sediment types, sediment properties, what is the topography either of the coastal system or the river system, and what are the boundary conditions. And then we can use the already existing softwares to actually model the sediment flow, or we can find what are the sediment hotspots within a particular region. In this way, we can might look into which are the regions which require a certain or immediate attention. Then, since the sediment transport is affected by what are the different kinds of sediments or what are the sediment classification, we have different ways of classifying sediment. Conventionally, what you do, you could have those grabbers where at particular location field sampling can be taken up, and then we could have laboratory experiments to consider what are the different type of sediments, be it sand, silt, or clay, or a mixture of them. However, these are time and time constraint is there, and then they also provide limited variability. So what we have the sediment classification using the satellite and the acoustic methods. So we could have a satellite imagery over large spatio-temporal ranges, which may range from years or sometimes decades as well, over a very large spatio-temporal range. And then we could apply some image processing techniques. Currently, we could have some artificial neural networks or AI-based methods as well, where we are able to relate the change in the turbidity or the to the actual sediment concentration, and also to look what kind of sediment it is. So we can get an understanding just through the satellite imagery, what would be the sediment type, what would be the sediment concentration in itself. Another way is using acoustics. So here what we can do is we could have sonars, which again could be of different types. We could either have the acoustic, the single beam echo sounder, the multi beam echo sounder, the side scan sonars, So again, depending on what is the frequency or what is the benefit of the sonar, we could deploy the sonar within a particular river, water body, and then we could see the data which is collected by that sonar. Because each and then using that we can understand what is the bathymetry of the riverbed or of the seabed itself, and then we can have some maps. Now we can see here these are kind of static maps. However, when we talk about acoustics and apply proper data analysis, we can get dynamic. We can try to combine the wave currents, the sediment type, the sediment transport dynamics itself to see how the variation of sediments is happening, because sediments are not static, they are susceptible to changes due to wave currents itself. So how the combination of different parameters actually lead to the sediment transport and the sediment classification, that can be looked into. I'll speak more about it in the later part of the presentation. Now coming to the various sport sediment classification, but what are the various issues that are caused by this sedimentation? One of the challenging part is the shoreline erosion. Now, nearly 40% of India's coastline is affected by erosion, especially due to high waves, tides, currents, especially in Kerala, Tamil Nadu, in Gujarat as well. We see there is a lot of receding of the coastline itself. Now, most of this, these can be attributed to the wave currents, to the tides as well. But how does the sediment, which are influenced due to the nearby rivers, say the vessel movement, how the vessel movement leads to the redistribution and leads to the erosion or accretion. Now, if there is this shoreline erosion, how is it affecting the overall socio-economics? How is it affecting the marine biodiversity? All of these local sediment dynamics remains vastly unstudied. There are isolated studies, but over a large scale, the the erosional studies seem to be lacking, where again, these might affect the overall offshore foundation. If there is a port nearby or a breakwater nearby, how that would affect the overall erosion rate or the shoreline erosion. So all that can be solved by modeling and simulation itself. Now, if we see in this animation, if sedimentation within a particular navigational channel or say a port, as well, if it goes unchecked over years, it may get accumulated, and then it affects the available draft for the particular navigation channel and can lead to delays, cost overruns, and the overall efficiency of the transport mechanism in itself. So, what are the solutions of solving such sedimentation? The one such solution comes to our mind is dredging. So what to do, you understand what is the amount of sediment that needs to be removed to maintain a particular drop, and then amount of we could have mechanical dredges. There are a lot of machines which need to suck up the sediment, and then that can be later transported to somewhere else. However, this dredging is not a long-term solution. It's a very reactive kind of solution, and the effects or the ill effects of dredging, it has a lot. It leads to redistribution of sediments. This redistribution leads to the effect on the fisheries as well. Also, say in a particular region, if dredging has happened, however, if no proper sediment dynamic study is done, due to the anthropogenic activities or due to the natural factors, if that dead sediments get redistributed again within the same space, again the dredging story goes on conducted the next year around. So it is a never-ending cycle. So what we need to look into is what are the other solutions. If we can look into what are the where actual dredging is required, and it will not lead to other overbearing effects on other cases. And this is where actually a sediment transport study comes into picture, where we could understand what are the various sediment sources, how the seasonal variability all affect the overall redistribution of the disposal of the dead sediment. Now again, this dredging operations have construction of new ports as well. In fact, around 30% of the overall costs are required for setting up a new port goes into dredging. So we again, we do not have proper understanding of how much of this dredging volume needs to be, how much of the sediment actually needs to be dredged out. So we can see within the 12th five-year plan, actually the actual amount of dredging that was planned and which was carried out was around 47% less than the targeted volume. So there's a lot of lack of understanding in what is the actual sediment volume that needs to be dredged. Also, if we look into such kind of seabed, if we need to carry out such kind of dredging, how that affects, how the trawling might affect the overall corals, coral reef, the benthic ecosystem itself. So again, dredging has a lot of effects, and we need to understand the higher costs and the inefficiencies associated with dredging. How can we use our digital transformation in understanding what would be the sediment volume that is required, or can we look into what are the actual, or we can identify what are the actual hotspots for sediment, or what type of sediment needs to be removed, so that we can actually use a targeted strategy for even for the scheduling of dredging itself. Now, in cases of, say, unchecked sedimentation or unchecked dredging itself, in many cases, these sediments also carry a lot of pollutants, a lot of nutrients itself, and these might give rise to algal blooms, affecting the overall water quality or degrading the dissolved oxygen or the dissolved oxygen which is available for the fisheries within a particular water body itself. And if the overall water quality affects, the species distribution is affected, it has effects on the, say, the fishery communities, the coastal communities in itself. So the sediment affects the overall benthic ecosystem, it affects the water quality, that has overbearing effects on the coastal communities, on the social economics as well. And then it again comes back to the how the nature is affected. So it's a loop where we need to understand how the sediments actually have overbearing effects on the people, on the economy, and on the nature itself. Now, again, coming to the inland water transport, the most of the Himalayan regions as well. When we talk about the Yamuna, we talk about the Ganga. These start from the Himalayan region, from the upper reaches, and then flow from the plain within the northern regions itself. So how the various activities, the agriculture belt, how that affects the inundation, how that affects the overall influx of sedimentation that needs to be looked into, because if the irregular sedimentation is happening, it might affect the overall navigational draft within that particular inland waterway. And to maintain also the water which is influx from various dams, from various barrages itself, how that leads to a change in the sediment levels, that we need to understand. We need to understand how the data-driven river management. If you have proper discharge level data, we have understanding of the hydrodynamics of the real-time bathymetry, how that is affected with the changing water levels and the changing and the related marine health itself. We can maybe try developing some sediment forecasting models to actually see, okay, in a particular time, which navigational channel would require our help, or which would be of a serious concern. Now, coming to the freshwater systems itself, the sedimentation is a crucial issue in our reservoirs itself. In fact, the Central Water Commission also talks about a lot of sedimentation within our reservoirs. Now, this has effect not only on the loss of the reservoir storage capacity, but it also has effects on the overall structural stability of the dam structure itself. And then we also need to look into how this entrapment of sediments affect the overall water quality, and then they also trap the nutrients. Now, these nutrients might be crucial for the benthic ecosystem or for the marine ecosystems that reside in the downstream. So, if we are entrapping the nutrients upstream, how the species distribution, how those benthic ecosystem within the in the downstream region, they might be affected. Again, we are not quite sure of that. So again, there are a lot of environmental impacts as well. How the water quality degradation affects the turbidity, the pollutants, this water might be supplied to irrigation as well. So how that affects the overall food chain, how it affects the soil quality. Again, so it has overwhelming effects on the watershed management itself. Now, when we talk about a lot of challenges, be it inland water transport, the watershed management, be it port management itself, if proper sediment management is done, we are able to monitor what are the type of sediment, we are able to see what is the depositional rate. These can be of real use in many cases. The first one being sediment map, seabed mapping itself, or the riverbed mapping. Now, if we are able to utilize the acoustic sediment classification or the acoustic sediment transport mapping itself, we can use it in the planning of say undersea cable or the submarine routes itself, where we can actually able to see what are the seabed bathymetry, how that gets evolved, the changing climatic conditions with the various anthropogenic activities that might come in help. Also, a lot of mineral, the polymetallic nodules are within the Central Indian Ocean basin as well. So, such kind of sensing or such kind of equipment be of help within those particular domains as well. Another crucial application is within the sediment bearing capacity. So sediment bearing capacity, it can be understood as the maximum strength that the soil can carry prior to filling. Now, this is mostly based on what is the sediment type, what is the cohesiveness, what is the friction angle of the sediments. It quantify what is the overall sediment bearing pressure. However, we have seen examples where improper sediment bearing pressure understanding have led to a lot of detriment to the infrastructure itself. So we have seen that due to lack of understanding of this covering, how the sediment transport patterns actually evolve, there is effect on the overall stability of the offshore foundations of these foundations, and it can lead to different settlements as well, and then it can lead to say the restriction of again a lot of infrastructure, and then how sedimentation it leads to a loss, or it can lead to scarring, it can lead to attrition. So how the change in sediment levels, so the change in sediment types affect the bearing capacity. That needs to be looked into. And because it has a lot of applications, say in the offshore construction, where we talk about the bearing pressure, what is bearing capacity, in understanding what is the foundation design, or say for the oil rigs, for any offshore bridges, even in the cases of dams, where we find what is the overall bearing capacity or the strength using the type of sediments itself, and then the sour behavior, the sediment mobility, all of it affects the foundational stabilities itself. Now, this sediment bearing pressure finds its application within the defense operations as well. Now, where we can look into how the different sediment types, be it silt, clay, or the gravel, it affects what is the sediment bearing pressure, which might affect what is the type of equipment that can be deployed within that particular region. Now, there might be a sediment regime change due to the increased fluctuations of climate change, or the change in geography, how that rapid inundation might affect the sediment, how it might affect what is the sediment type, or what are the sediment levels, and then how it affects the overall structure. So if some reclamation needs to be, then this needs to be for even for say mine burial or say anchor holding as well. So what are the different, how does different type of sediments play a crucial role? That needs to be looked into. Yeah. So especially when you talk about the bridging operations, or we have said the amphibious operations as well. So there is a prior understanding of what is the sediment, whether the current soil or the current sediment is able to capture that or take up that much load, and such prior studies might give us an estimate of which region is suitable for such heavy equipment deployment itself. And then we also can see that the Indian coastline, there are sediments of different types, ranging from clay, sand, silt. So again, this is a static map, but depending on what are the climatic conditions, the coastal conditions, these might vary a lot with the pre-monsoon, the monsoon, and the post-monsoon. These might indeed vary a lot. And again, we have different kind of sediments. Say from the runoff cuts, we could have mud flats, salt crust, where we could also find coral sands or volcanic sands in the Andaman and Nicobar Islands as well. So how that affects the overall bearing capacity, where the clay silt might have very low bearing, which is similar with the marshes of say the Sundarbans as well. While if we could have gravel kind of thing, which would have high bearing capacity. So how it has a different kind of application, different kind of bearings on each other, where the high bearing might not be so much interest, but in cases of the critical bearing capacity, we need to look into what are the issues there, what are the actual parameters that affect the bearing capacity within the particular region itself. And then, as I mentioned, it is very much required for the temporary structures like bridges, docks, or defensive fortifications as well. We need to understand what for the heavy vehicle deployment or for amphibious operations as well, how much being a highly permeable kind of material in the submerged conditions, how that is affecting the overall strength of the particular soil medium or of the material. And even if we need to construct say, trenches, bunkers, or barriers in those shallow water regions, how that sediment bearing came into picture. So again, we can look into some of the technological or digital transformation tools that might help in understanding the overall bearing pressure estimates. And then such kind of sediment monitoring can also help in the benthic ecosystem monitoring, where we can see that how the change in the turbidity, say using satellite imagery, we can see how if the change in say the turbidity, or if we are able to model what are the sediment influx, different kind of transport patterns, how that affects the change in the nutrients, change in the say the pollutants within the sediments, how does it affect the benthic ecosystem, or even due to dredging, which leads to the redistribution of the sediments. How does it lead to a change in the spawning rates or in the habitats of the already existing fisheries or aquaculture itself? So we need to again sediment classification methods can be used here, and then again there might the acoustic methods can also be used to find what are different abiotic elements within a particular region. So one of the most prominent uses is are the polymetallic nodules, which are say globules of cobalt or nickel, which are very much crucial in the batteries as well. So Central Indian Ocean basin has a lot of these polymetallic nodules. So if we are able to use say, the sonars or sediment classification techniques to see where the polymetallic nodules are located, or we can understand how the seabed is varying in that region, so that again we can come up with proper mining techniques or extraction techniques itself. We can also use it to find what are the various ship debris and how the overall sedimentation or the sediment transport is affected by such ship debris. We can look into it. Now, once such kind of sediment transport equipment is into place, we can actually use it into different applications itself. So, say we have proper and acoustic surveys, which might lead us to understand the bathymetric and the sediment data. Now, once we have an idea of the bathymetric or the sediment data, we could get an understanding of what is the overall sediment volume. As the acoustic, uh, so due to this, what are the different layers of sediments and what are the thickness of the sediments, we can get a quantified understanding of what is the amount of sediment in a particular stretch of water body. And with using the sediment classification techniques, we can see what is the actual type of sediment. What is the grain size distribution, what are the chemical composition, or what is the cohesiveness of the particular sediment type. And then that can be used in various applications, say for the dredging. We can understand if we know what is the actual dredging volume or what is the sediment type. We can say whether a hydraulic dredger is required, whether a mechanical dredger is required, or what kind of dredging is required, what is the frequency of dredging is required. If that particular dredge sediment can be reused again, if it satisfies proper engineering characteristics, can we use it for proper offshore disposal, or can be reused again within that particular region for land reclamation or for fertilizers or for even for brick construction as well. Again, such kind of use of the dead sediment, it might lead to potential cost savings as the overall transport cost might be again gets reduced, and then it also leads to opportunities for carbon dioxide savings, because now the dead sediments can be reused again within the land. So, for example, in a port, in a construction of a new port, the dead sediments can be again reused for the land reclamation, creation of backwaters of jetties itself. So you see, it has effects not only on the nature itself, but on the overall cost savings and on the economics of the sediment management and the infrastructure development itself. Likewise, within the watershed, if we are able, say, using satellite imagery or using patterns, we are able to assess what are the different land use changes over time, what are the soil type changes, or what is the erosion that has happened. We can identify which are the particular hotspots that actually lead to the sediment influx, or where urgent requirement is urgent care is needed. And then we could have appropriate catchment area treatment. So we could have either say trenching type, silt traps can be formed. We could have check dams or afforestation. So again, dredging is not the only solution that we can look into. And then such kind of proper sediment monitoring and understanding of what is the maximum level of sediment that can be reached within, say, high flood levels, extreme flood levels, or extreme drought levels. If we know what are, say, the pre-flood conditions, and using the simulation techniques, say, under different conditions, we are able to map what would be the maximum post-flood channel. We can actually come up with disaster management plan in the plans within the urban planning itself to see what would be the safe extent across which, say, infrastructure can be planned, or like livelihoods or housing can be planned. So all of this can be incorporated with the disaster risk management itself. It is in the current age we can call as the predictive planning, and instead of a more reactive kind of approach, we can move towards a more proactive approach where we have understanding of a local dynamics. We can actually use the actual evidence. We can understand what are the local realities, and that can be included within the different kind of frameworks and different kind of models to actually go towards a more data-driven kind of an approach. So the major challenge, however, lies, say, even if studies are conducted, say, for sediment transport, sediment classification, what are the wave currents, what are the different climatic conditions, the major issue is there is no single platform that connects all of the data together. So some studies might be conducted by some research institutions, some might be conducted by some other government organization, some data might be lying within the military itself. So how are we bringing the different data all together? Because again, such kind of data cannot be shared with all of the stakeholders, considering the strategic importance of that the bathymetric data or of the sediment type itself. So how can we actually look into the combination of data, correlation of the data sets between one another? So this is where our contribution lies, where we look into how the data fusion can happen, where we have data-driven approach, and we can see how can we develop or understand a local region-specific sediment dynamic within the marine spatial framework, and that can be then used within the scalable and adaptive system, so that that can be again used for a wider audience. So I'll give us an example. So say we have the Brahmaputra region, which is inhabited by around 500 million people, and then we know that due to a lot of flooding, it is susceptible to a lot of flooding, to a lot of change in the morphology, a lot of rainfall happens, so it leads to a lot of flooding. There is a change. The riverbanks might be overflowed and leads to a lot of infrastructure damage as well. So what might be the solution? How the acoustic sensing techniques and the remote sensing can actually help us. So say we could have acoustic sensors or voice or the acoustic Doppler current profiler at certain locations, so that we are able to get real-time data, say, for what are the suspended sediment concentration, what is the water level, the discharge levels, and then using that continuous data, we might load it into our different kind of models to understand what is the sediment flux, what are the hotspots which are prone to deposition and erosion, which might be useful for dredging, for understanding benthic ecosystem, to actually map the urban flood or the extent of the flooding that might happen within the particular region itself. So what our approach is, say for a particular body of water or region of a proper field validation, where we look into this, either say the satellite data or the acoustic field validation can happen to, or the understanding of the local conditions to actually understand what is happening. And once the field validation has been conducted, we have proper data analysis. So the thing is that the acoustic data or any kind of field experiments, they will give you a raw data. Now that might be prone to noise, the medium propagation due to biological noise, or the variation due to some say shipping itself. So how are we determining or extracting actual information from the raw acoustic noise? So that requires proper pre and post processing algorithms, be it in the domain of AI, machine learning, or any other mathematical models. And then that analysis, they can be overlaid with each other over a marine spatial planning tool, where we could have different, say, the wave effects or the sediment type, the sediment transport, all of them can be laid together, and then using the AI and predictive modeling under different conditions, we can predict, say, under extreme drought condition, under different flooding conditions, under different hydrodynamic conditions how the actual sedimentation is affected. One such study has been conducted by MRC for the Khadakpasla, where the acoustics were used to actually classify the type of sediments. So we had different bottom profiler, this and that. These were mounted on ships, and over a span of 2 days and over 5 tracks, the acoustic survey was carried out. And once that acoustic data was carried out using the various sonars, we also had various CTD measurements, which is the understanding of the salinity, the water temperature, and the pressure with depth, so that an understanding of how is the speed of sound varying within that particular medium. As the speed of sound varies with the different salinity, temperature, and pressure, we are able to estimate what is the overall processing that is required for the raw acoustic data. Now, such kind of acoustic data, it might again have a lot of filtering. It might be required. Pre-processing, post-processing algorithms are required, and based on some mathematical formulation, and reflection coefficient was calculated for the data. So, reflection coefficient is the ratio of the received to the transmitted energy of that particular sediment. Now, this kind of reflection coefficient, these were mapped for different for all of the survey types, and these reflection coefficient can be mapped to unique kinds of sediments. Now, this reflection coefficient tells that the most of the bed is formed from the clay silt kind of mixture, and this was actually validated by using 5 to 6 field samples itself, where the laboratory experiments showed that the composition is actually silt to clay type. So this actually talks about the overall validity of the acoustic sediment classification itself. Then we also carried out the satellite-based sediment classification or the suspended sediment concentration understanding within the Ujjaini reservoir itself. So what we had, we took the satellite imagery of the overall Ujjaini reservoir, and for 3 different periods, for the pre-monsoon, during monsoon, and the post-monsoon, we were trying to estimate what is the change in the turbidity or what is the change in the sediment concentration. Now, such kind of satellite data which can be derived say, from the Copernicus websites. So such kind of data is actually extracted in terms of spectral bands. Now, if we are able to utilize proper relationship between the spectral bands, we are able to see, say, for example, here we have plotted the red to green ratio, which is nothing but the value of the red band to the green band for that particular satellite, and the red to another kind of ratio. When we get the pre-monsoon and the post-monsoon, there is a significant ratio rise is attributed to a higher sediment reflectance. So, a lot of empirical have been done where the actual sediment indexes or the spectral indexes have been correlated to the sediment concentration, and these have been leveraged to actually look into a change in the sediment regime and the sediment type itself. Another work that has been done is to understand how the extent of sediment flow or sediment concentration that happens. So we have the stretch of Brahmaputra River. We are using the digital elevation models, the hydrodynamic models. We are able to estimate, say, which would be the potentially flooded regions, which areas might be significantly affected, and which might be the affected urban regions. Also, we can estimate what is the suspended sediment concentration across different stretches and different time scales itself. So this is where satellite data can come into a picture to actually map what is the extent of say urban floods that might happen. Now another issue is the navigation, as I mentioned. Now, say for a particular chosen stretch of the Brahmaputra River, due to changing of the water levels or change in the sediment concentration, stretches which might not be navigable. The overall draft which is required to maintain draft is required might not be maintained for year long. So, would we be able to actually model within particular say input condition, input sediment condition, or the water levels, which would be the most optimal path, or what would be the navigational channels which might actually have the prescribed draft. So what we did, we actually had the sediment, the satellite data from the monsoon and the post-monsoon within a particular stage of the Brahmaputra region, and then we did a 5-class segmentation map. So red on the green one is the land area, the blue one is the actual river and its tributaries, and the nearby areas are the which are in the orange color are the marshlands. So once we have the segmentation map, we give a cost map. So the land area might be 0, while the water and the tributaries, they might be given say a cost of 1. So here we are trying to give a cost map of what might be the actual navigable stretches. Now then, based on some input conditions of what is the sediment type or what is the sediment distribution, we try to run for a given input condition what would be the optimal route for navigation. So here we can see within the blue bar, we are able to see what might be the optimal route, and then we are also able to identify, say, for a green kind of identification that might be safe for navigation. Orange talks about that it might have moderate risk associated with sedimentation. Well, red shows again it shows a lot of land area for now, but the nearby regions might show critical regions where excessive sedimentation is happening. Kind of sedimentation also affects the shoreline erosion. So what we have done, we have taken a particular stretch along the Konkan region itself and tried to see with changing wave conditions, hydrodynamic conditions, how the shoreline is varying. So again, by utilizing the satellite imagery, a particular stretch of the of the shoreline was discretized, and then such kind of discretized was done for different kind of years. So say for 2023, 2024, and 2025, these were overlaid with each other to actually see what is the change in the shoreline across the different regions, and then that can be attributed to what is the change in the wave conditions or the sediment bathymetry itself or the sediment transport in itself, so that the shoreline erosion can be monitored, and then we can see how the accretion or the erosion is happening, especially nearby the ports, nearby the tidal inlets. So again, a lot of mathematical modeling can also be used for this shoreline change modeling itself. Another project that we took up was to assess what is the dredging volume. So in this case, a case study within the Cochin port was taken up, and the maps of the Cochin port was imported in a software called the Hackras and the Telemat, where we tried to, based on the available data sets of say, the wave conditions on the discharge levels, we were able to get what is the depth of the navigation channel within a region, and what is the mean shear stress of bed shear stress within that particular region itself. So now, once you know what is the shear stress, that can be used to identify what is the or how the sediment transport is, and then what is the current bathymetry. We were able to identify what would be the estimated raw gross sediment that might be need to be removed, and what would be the non-dense amount of sediments within that particular region itself. Sediment management has a lot of dimensions, be it from port management, inland waterways, benthic ecosystem, watershed management. But what we need to look into is how we are connecting the dots, how all of them are correlated with each other, be it the coastal communities, be it the coastal infrastructure, how the overall people, economy, and the nature, all of them are connected with each other. And again, this is where like the phrase that the nature whispers before it roars. So if we refuse to listen, the roar becomes the ruin. So it's very much crucial to understand what the nature is trying to say, to have the data with us to understand what might come, and again we can just prepare ourselves for the for any kind of changes to come. So I think, yeah, thank you for enjoying.